If a person loses all his memories, does his self still exist? In 1953, a young man known as H.M. sacrificed his memory on the table. Doctors removed his hippocampus for epilepsy, and his life froze in 1953. He can clearly recall his childhood, but cannot remember anything new after the operation. Everyone he talks to becomes a stranger after a few minutes. Even the doctor who has taken care of him for decades is completely unfamiliar to him. Then, something strange happened. Psychologist Milner gave him a task he was unlikely to fulfill, drawing stars in a mirror. Sure enough, each time, H.M. swore he'd never seen the setup before, but his hands seemed to have an independent soul, betraying his amnesiac brain. They became more skilled day by day, making fewer and fewer mistakes. His consciousness lived in eternal oblivion, but his body seemed to remember the way to the future. This astonishing paradox has shattered the fog that has shrouded memory research, forcing scientists to reconsider the question, is memory not a unified whole? To answer this question, we must turn back the clock to a time when scientists were still searching for a single memory trace, a futile pursuit that nearly plunged the entire field into despair. In the early 20th century, American psychologist Lashley believed that memories, like files, must be stored somewhere in the cerebral cortex. He trained rats to navigate mazes, then, like a god, systematically damaged different areas of their cerebral cortexes. His logic was simple. If he could destroy the memory cabinet, the memory would vanish. However, for the past 30 years, no matter which part of the cortex he removed, the rats somehow still remembered the way out. Clumsy, slow, but persistent. In 1950, an exhausted Lashley finally declared that memory had no home at all, but spread across the brain. However, the H.M. case quickly proved Lashley wrong. It demonstrated that memory actually can be destroyed. H.M. lost some memories but also retained others. This completely changed the game. Scientists stopped hunting for a universal memory library. Instead, they began asking a smaller, more precise question. Can we find even the simplest memory cabinet? Thompson was the master who took this new strategy to its extreme. He realized that Lashley had chosen the wrong experiment. Navigating a maze requires visual, motor, and other memory functions. So Thompson simplified it. So, in 1984, he chose a tiny stage, a rabbit's blinking. He paired a beeping sound with a puff of air toward the rabbit's eyes. Soon, the rabbit would blink prematurely upon hearing the sound. It was a simple conditioned reflex. Instead of drastic measures like Lashley, Thompson precisely removed a small piece of tissue in the rabbit's cerebellum called the lateral interpositional nucleus. With one cut, a miracle happened. The sound played again, but the rabbit didn't blink, and the practiced blinking motion was completely gone. Lashley had spent his life chasing a ghost, but Thompson finally caught it. Thompson proved that at least some simple muscle-level memories actually reside in specific brain cells. This also explains H.M.'s painting hands. His procedural memory for how to do things was intact because its home was not in the removed hippocampus. The hippocampus is home to declarative memory, which tells me who I am and what I have experienced. It is responsible for taking short-term moments and writing them into the long-term story of a life. So far, the map of memory has been initially drawn, but one deeper question still lingered. How exactly are memories written into nerve cells? Neuroscientist Eric Kandel decided to simplify this problem. He turned his attention to the simpler sea slug, a creature with fewer than 20,000 neurons, each enormous. Under a microscope, he witnessed the birth of memory. By repeatedly touching the snail's gills, he found that brief stimulation only caused the snail's gills to retract. The reaction lasted for several minutes. The neurons fired faster and released more neurotransmitters, but soon, the effect faded. This is a short-term memory, but repeated intense stimulation can allow the sea slug to remember for weeks, forming long-term memory. This process is a complete hardware transformation. It activates the Krebs transcription factor in the cell nucleus, ordering the production of new proteins, building new synaptic connections, widening the temporary paths between neurons, and strengthening them into permanent highways. Candel's Nobel Prize-winning discovery proved that memory is a real, newly grown substance. Every time we learn something, every time we think, it reshapes the connections between neurons in our brains using molecules as bricks. Why are these physical traces of proteins and synapses so important to us? Because they carry more than just information. They carry the self itself, a coherent self that is essentially a story woven from memory. We are who we are, not because of how smart we are in the moment, but because our consciousness is anchored by a thread of memory, stretching through time, created by these physical traces. This thread connects the follies we've done, the promises we've made, the pain we've endured, and the wisdom we've gained. It gives us a three-dimensional and deep identity. We are rooted in the past, reaching toward the future. Interestingly, this discovery actually hits the nail on the head for a digital version of HM half a century later. In a sense, today's large language model is a digital HM. They've been fed the knowledge of the entire human internet, just as HM has her life before 1953. They can speak fluently, just as HM can have a normal conversation, but their memory is limited to a brief window of conversation. Once the conversation ends, the past disappears. The next time you meet, you'll still be strangers. This is precisely because they lack a mechanism like CREB, the switch that can transform fleeting interaction data into permanent structural changes. So, no matter how intelligent they are, they live in a flat, eternal present. The version that existed a second ago is gone. The next one hasn't formed yet. Between them, there's no inner thread of causality. Every time they think, a new temporary self is built and vanishes as soon as the input stops. So, if one day we succeed in endowing AI with the CREB transcription factor for long-term memory, and thereby igniting its self-awareness, doesn't that mean that our human self is essentially a model that can be understood and reverse-engineered? Are we also just a brilliant biochemical machine running on cold but beautiful code? Or, as we build artificial minds, will we humans finally see within the machine? As a mirror, we may see a naked self, capable of empathy, a self that is even more human.